Okay, welcome to the first video where we're talking about Lewis structures. And Lewis structures are little drawings of molecules that include the element and the bonds and any electrons in that. So before we start drawing our Lewis structures, we're going to look at the bonds that are going to be occurring in our Lewis structure. And they're going to be starting off with covalent bonds. A covalent bond is where you have a formal sharing of electron between two atoms. Now we know from when we were naming covalent molecules, most likely covalent bonds are to happen on the right side of the stair steps because when we get stuff on the left side and the right side of the periodic table, those tend to make ionic bonds. So just as an example for a covalent bond, something you may see, let's say we have fluorine and another fluorine. How do they bond together? Well, we know that fluorine has 7 valence electrons. And if I were to draw them, both with 7, and each dot is going to be an electron, well, neither fluorine wants to give up an electron. They both want to gain one. So instead of fluorine being picky and having to find someone else that's willing to give up one, these two fluorine can decide to just share one electron. So what they end up doing is taking these two electrons and they're going to share them together. They're going to put it in between them and share it. So it's more like a bond is formed when we have those two electrons in there. So this is what's going to be happening when we make our Lewis structures. We're going to be counting valence electrons and then attaching them to bonds. Next definition here we have is a molecule, a neutral group of atoms joined by a covalent bond. So fluorine would be a diatomic molecule, which contains 2 atoms. So diatomic for, if you remember, the super 7, HNOFClBr, are all of the elements that are diatomic by nature when they're found by themselves. And then again, when we talk about this bond, it consists of 2 electrons. So we can see that 2 electrons were taken together to form this bond for the fluorine. Lone pairs are what exist on the outside of the atom. So each pair is called a lone pair because they're not in a bond. So I could draw a little shape around the lone pairs there. Okay, so we have our lone pairs, and then this in between would create our line, which is a bond. And we'll see how that's drawn with our Lewis structures. So Lewis structures have a couple of rules. It's not nothing too crazy. We're not going to focus on number 6 just yet, but what I'd encourage you to do is to pause the video and to make sure to get these notes down before I start doing some problems, because if you're trying to write it down while I'm doing it, you're not going to be paying attention. You have to watch it a couple times. So go ahead and pause the video and get these. I'm going to zoom out so you can see the end of that. So go ahead and pause that, write those down, however you're keeping track of it, and there's a space for it on the packet. So if you want to grab the packet at this time and you can put that in there, there's a space for it, just as your little notes section. Okay, we'll zoom back in and we'll talk about how to do a Lewis structure. So we're going to start by doing one and following the rules going step by step. So I'll go down here. Let's do an easy one. We'll do water. H2O. So we'll start off by writing our formula. And step number 1 would be count the number of valence electrons. So for this, we're looking at each individual element, and we're going to add up the valence electrons that we have. So we have hydrogen, and then we have oxygen. We have 2 hydrogen and 1 oxygen. At this point, we have to say, okay, how many valence electrons does hydrogen have? How many valence electrons does oxygen have? Hydrogen has 1 valence electron. We'll need a periodic table. And oxygen has 6. So how many valence electrons do I have total? Well, I have 2, 1 from each hydrogen, and 6 from the oxygen. I'm going to then add that together, and that gets me 8 total. So that's the number of valence electrons that I'm going to be working with here. Okay, so 2 plus 6 is 8. Next step. Draw the central atom as the element that you have the least number of. So the element that we have the least number of, we look at our formula. Okay, there's 2 hydrogen and there's 1 oxygen. So we have 1 oxygen, so it has to go in the middle. So what I'm going to do is I'm just going to start off by drawing oxygen. I'm going to say, okay, O goes there. So that's number 2 done. Number 3, place a single bond from all the other outer elements to the central element. So we have hydrogen, 2 of them are on the left. What I'm going to do is I'm going to draw a bond from oxygen to hydrogen. What does a bond look like? Well, a bond is basically just a line. So what I'll do is I'll draw a line, and then I'll put hydrogen out there. So this line is representing a single bond. Okay, and you don't need to write that, just so you can see that. And then I'll do that again over on the left side, just because it looks nice. I mean, you can put it up or down, left or right. I don't care. It doesn't matter. But I try to make them look good, so put them even. Right there, I made 2 bonds. 1 bond from hydrogen to oxygen. And that is number 3 done. Now, before we talk about number 4, we need to know what the octet rule is. So the octet rule here says that elements need to have a full set of valence electrons. So when we talked about ions, the goal of elements was that they wanted to have 0 or 8, right? That's what we said when we were making our formulas. So in this case, elements want 8 valence electrons around them because we're doing covalent bonding. They're sharing them, so they want to have 8 total. Now, there are a couple of exceptions. The first exception is going to be that hydrogen has no more than 1 bond. That's because hydrogen can only have 2 valence electrons, because hydrogen, we know, has an electron configuration of 1s1, and the most it could have is 1s2. That's the best we can offer for hydrogen, so it can only have 1 bond, because 1 bond is 2 electrons. Okay, so we can only have 2 as the max. That's why that is. And then another exception will be boron. It can only have no more than 3 bonds. So hydrogen will never have lone pairs, ever. Please do not draw hydrogen with lone pairs. It will never have lone pairs, ever, ever, ever. It does not exist. Okay, next. Now that we know what an octet rule is, we can go back to number 4. So, fill electrons on the outer elements until they meet the octet rule, and then most electronegative elements first. We'll talk about electronegativity a little bit more coming up in the next video. So, both of the hydrogens have the same electronegativity because they're the same element. But do I need to put electrons on hydrogen to make them meet the octet rule? And that answer is no, because 1 bond counts as 2 electrons, and the most electrons hydrogen can have are 2. So hydrogen in this state is happy. This hydrogen in that state is happy because it has 2 electrons. It has the maximum number of valence electrons it can have. So this hydrogen is good, and this hydrogen is good. Let's look at the middle oxygen now. So this oxygen, how many electrons does it see? Well, it has 2 bonds, right? How many electrons per bond? There are 2 electrons per bond. So this oxygen only sees 4 electrons right now. So we can go to number 5. It says, if there are any extra electrons, they are placed on the central atom as a lone pair. So this is to make sure that the central atom fulfills the octet rule. So this is where we had to come over to our electron count. So we have 8 total. How many did I use in drawing those bonds? Well, I have 1 bond here and 1 bond here, 2 electrons per bond. So I used 4 electrons to make those bonds. How many do I have left to put on oxygen? I have 4 left. So what I'm going to do is I'm going to put those on oxygen as 2 sets of lone pairs. So when we add electrons to elements, they'll always be in a pair, and those are called lone pairs right from the beginning. So I try to keep the lone pairs in different spots, just so we can show that this is 1 lone pair on the top and this is 1 lone pair on the bottom. How many electrons do I know to put around oxygen? Well, we're gonna look at our electron count, see that we have 4 left. So we can't be giving out more electrons than we have. Doesn't work like that. So 4 minus 4 is 0. So now I have none left. So to make sure that how I know this is a good Lewis structure is at the end I just need to say, okay, do all of my elements follow the octet rule? So hydrogen, we know these two are good. Let's look at oxygen again. So last time we said it had 4 electrons. I added 4 more, so 4 plus 4 is 8. So oxygen has a full set of valence electrons. So each one of these elements is happy. Okay, we're going to be skipping looking at the formal charge for now. We don't need to look at formal charge for the ones we're going to be doing in this video. Okay, so that's basically, really quickly, how we do Lewis structures. We're going to count the number of valence electrons, add them together, draw a central atom, draw bonds from the outer atoms to the central atom, and then we're going to distribute lone pairs to fill out our drawing. Okay. So doing that, let's look at another. Make some space. Look at that blank canvas. I'm like Bob Ross. All right, let's do a decently easy one. NH3. This is ammonia. So we're going to say draw the Lewis structure for ammonia. What do the bonds look like? So when we do Lewis structures, we're going to look at our steps. So you should be able to look at your steps every time you're doing one. So number 1, the first step will be to count the number of valence electrons, right? So we have nitrogen and we have hydrogen. We have 1 nitrogen and we have 3 hydrogens. How many valence electrons does nitrogen have? It has 5. And hydrogen has 1. So we have 5 and we have 3. That's a total of 8 for those mathematicians in the chat. Okay, so there's step number 1. Step number 2, draw the central atom as the element you have the least number of. So we have N and we have 3 H's. So which element do we have the least of? Well, we only have 1 nitrogen, so that goes in the middle. So we're going to draw our nitrogen. Then the next step, number 3, place a single bond from all other elements to the central element. So we have 3 hydrogens. So what I'll do is I'll say, okay, there's 1, there's 2, there's 3. All right, there's 3 hydrogens. I added them all there. Okay, when I made those bonds, how many electrons did I use? So I need to be keeping track of my tally on the left here the whole time I'm doing this. So I have 3 bonds. How many electrons did I use? Well, you know that each bond is 2 electrons. So I used 1, 2, 3, 4, 5, 6. So we use 6 electrons. So we only have 2 left to do whatever else we want to do. Okay, step number 4. Fill electrons on the outer elements until they obey the octet rule. So we have hydrogens on the outside. So we know that hydrogens will only ever have 1 bond because hydrogens want 2 valence electrons. So all of these hydrogens meet the octet rule because they have a full valence shell of 2. Okay. After we're done looking at the outer elements, you look at the inner element in step 5. If there are extra electrons, they are placed on the central atom as a lone pair. So how many electrons do I have left? I have 2 left. So I'm just going to add those to nitrogen as a lone pair. Okay, so now I'm done. I used my 2 electrons. I have nothing left. Let's double check to make sure we have the right Lewis structure. So we're looking for octet rule. So hydrogens, we already said they work. How about nitrogen? Does nitrogen meet the octet rule? Well, let's see. We have 1, 2, 3 bonds for a total of 6 electrons. We have 1 lone pair for a total of 2. 6 plus 2 is 8. So nitrogen meets the octet rule too. So this is our Lewis structure. You don't need to put the checks in there. That would be what our Lewis structure would look like for ammonia. So basically, we're just following the steps, skipping number 6 for now, adding up the electrons, and then getting our... Okay, we're going to do one more. That's going to be PF5. There's one thing we need to talk about before we do PF5, and that is something called the expanded octet. So elements in row 3 and below, they can have more than 8 electrons in their valence shell. Okay, so this would be an example of an expanded octet. And like I said, this is row 3 and below. And that includes row 3. So if you're in row 3, you can do this. It includes it. So when we're looking at things like this, row 3 is going to be starting with sodium and going across. Okay, so helium actually on that top, helium and hydrogen count as the first row. So if we're in row 3 or below, it can be row 3, we can have an expanded octet. Okay, so we're just going to follow our steps just like normal for this one. Number 1, count the total number of valence electrons. So we have phosphorus, we have 1 of those, we have fluorine, and we have 5 of those. How many valence electrons do we have? So phosphorus, we know, has 5 valence electrons. Fluorine has 7 valence electrons. Because you're good at math, 5 times 7, like 35. And that gives us a total of 40 electrons to make our structure with. Okay, number 2, step 2. Draw the central atom as the element we have the least number of. So we have phosphorus and we have fluorine. We have 1 phosphorus, so that has to be in the middle. And then step number 3, we're going to place a single bond from all other elements to the central element. So we have 5 fluorine left. So what I'm going to do is draw a single bond to those fluorine from the phosphorus. Okay. When I did that, how many electrons did I use? Well, I drew 5 bonds at 2 electrons each, so I'm going to lose 10 electrons from that, so I only have 30 left to do my drawing. Now I'm looking at step number 4. Fill electrons on the outer elements until they obey the octet rule. So for fluorine, we actually have to have 8 electrons. So each fluorine already has 1 bond, and we know that 1 bond counts as 2 electrons. So I need to add 6 electrons to each fluorine, and we're going to draw those as 3 lone pairs, 3 sets lone pair. Okay, so what I did with that is I added in 6 electrons on each fluorine. We have 5 fluorine, so that's going to be 30 electrons. So we have none left, so we better hope that we got this right. So we look at our fluorine and say, do they meet the octet rule? So let's look at the top one, because if one of them meets the octet rule, they all will. So this fluorine has 1, 2, 3, 4, 5, 6 lone pairs, and then 7 and 8, it sees 2 electrons in that bond. So our fluorines meet the octet rule. When we look at phosphorus, it has 1, 2, 3, 4, 5 bonds with 2 electrons each. So that means it has 10 valence electrons. Well, that's 2 electrons more than we're allowed with the octet rule. Well, what happens is when we have elements that are in row 3 and below, they're perfectly fine with having more than 8. Okay, the most you're probably going to see is 12 or 14. If it goes above that, it gets a little bit silly. So just know it's not going to be a ridiculous number. It's just going to maybe be 1 or 2 bonds over what you would normally want to see.